Alright, I'm going to be doing a review of mathematics topics required for the Utme examination. So I'll start by looking at set. I've already done the set theory part of it. So I'm going to focus on the Venn diagram. I'm going to focus on Venn diagram involving only two set problems. Venn diagram involving only two sets. Venn diagram involving three sets can occur in examination, but the focus should be on two set problem. So if there is time to cover the three set problem, I will also do so. So, what are the attributes of a Venn diagram? A Venn diagram consists of a universal set U. Let this rectangular box represent the universal set, and it will have two other subsets inside the universal sets, which are the proper subsets of universal set U. So let the first cycle represent the first proper subset, and the second cycle represents the second proper subset. So if you look very well, you discover that there's a portion of overlap here, which will represent where elements of, let's call this set A, and let's call this set B, where elements of members of set A or elements of set A and elements of set B are common, where we have common elements or the point of intersection. So this is a point of intersection. This portion here, aside this point of intersection, only this portion here represents all the members of elements in set, all the members of set A or all the elements in set A. Only this portion here represents all the elements, members of the elements in set or elements in set B. Okay, members or element, not both. So this portion represents what is common between them. And of course, you must not forget these outside parts, because this universal set has members here which are not part of A and not part of B. So let's call that part, let's call it Y. So that means set Y represents elements that are neither in A nor in B. Okay, so the universal set is represented as such. So there are four things or four components here. You can see this portion here is 1, this portion here is 2, this portion here is 3, and what is not in either of the two sets is 4. So we have 4 compartments of a two-set problem. So I'm going to look at what each of the compartments represents. The first compartment here will represent what? Represent number of elements in A only. Number of elements in A only. Why? Because if it's a number of elements in A, it simply means even all to this point, even including this part of 3. But we're looking at only A. That is, if it is a subject like physics and this is chemistry, we can say number of students offering only physics, for instance. So this is the number of elements in A only. And the second portion here represents number of elements in B only. And the third portion here represents number of elements in what? In A intersects B. Number of elements in A intersects B. And of course, this outer part of the set here, which is neither in A or in B, represents what? The fourth part represents number of elements in what? In A union B prime, which means it's not in A, it's not in B. That's why we put a prime. Prime means it's neither in A nor in B. Okay? So that's what the fourth portion here represents. There's this outside part, this set Y. That's what it represents. So these are the 4 elements. And of course, the universal set U, the universal set U will be equal to what? Everything here. It will be equal to 1, 2, it will contain 1, 2, 3, and 4. So all these are found in the universal set. Okay, let me represent it, give you the formula to calculate sets like this. Okay, take note of this. The set, I will redraw the set here, but in a smaller form. So let's call this set A, let's call this set B, and let's call this set X and set Y. So the universal set will be equal to the number of elements in the universal set, which is n bracket u. Number of elements in the universal set is given by number of elements in A, full A, not A only, that is the whole of A, including the X part, plus number of elements in set B, that is everything in B, including the X part, minus, remember the minus, it's not plus, minus, number of elements in A interset B, minus number of elements in A interset B. That is, we are removing this portion. Remember, the whole A included here, the whole B included here. So if you add, it's just as if you have added the X twice. So that's why we need to remove it. This portion here represents X. This portion here represents the X part. This portion here represents the BX, the B and X. This portion here represents the A and X. So you can see that X has been added twice. So that's why we'll end up removing one of the X. Okay? Then plus, that's not the final answer, plus the one that is outside. Number of elements in what? A union B prime, which is the Y. This is the Y. So, and this is the universal set. Okay, universal set can be given as number of elements in A union B plus number of elements in A union B prime. Okay, that's what it can be given as. So I'm going to take 2-3 problems on this. Once I give you an exam, identify these portions of the set and know what you're asked to find. If this represents a full class, this will be the number of people that are offering physics, this will be the number of people that are offering chemistry, this will be the number of people that are offering both physics and chemistry, and this will be the number of people that are offering neither physics nor chemistry. If we're looking at 2 surveys, like 2 subjects, it can be in any form, it can come in anything, but there must be only 2 sets or 2 groups of items that can be categorized. That is when you know you are looking at 2 sets problem. Let's take an example. So let's say we have number 1. We have in a class of 80 students. We have a class of 80 students. 40 of us literature. 30 or 50 offers economics, and 20 offer neither literature nor economics. So this is the question. So how many offer both? How many students offer both? That is both literature and economics. So questions like this, how do you go about it? How do you solve it? So we have 80 students, that's a universal set. 40 offer literature, which is one of the subsets. 50 offer economics, which is the second subset. And 20 offer neither, which is what is not the element, that is a portion of the set that is neither A nor B, that is outside the 2 circles I showed you earlier. Then we are told that we are asked to find how many students offer both. We're looking for the intersection of the sets. So what you do is just write a formula. Remember that the universal set is given by number of elements in the first set, total number, which is what? Which is 80 plus the second set. Sorry, the universal set is 80. Then people that offer literature is how many? 40 offer literature. Then 50 offer economics. And we don't know the people that offer both. That's what we're looking for. Remember in the formula it is A, B minus both, then plus what? General. So how many offer both? Neither. So 20 offer neither. So it's going to be 40 plus 50 minus x plus 20 will give you what? 80. So what is it going to be? So if you do the mathematics, 80 is going to be what? This is going to be 110. 40 plus 50 is 90. 90 plus 20 is 110. So 110 minus x is equal to 80. you subtract we bring this x on this other side, okay? Then we bring this 8 to this other side. So you can see clearly that x will be what? So if x comes to this side, it becomes positive. This one comes to this side, it becomes negative. So it's going to be 110 minus what? 110 minus 80. And 110 minus 80 will give you 30. So there are only 30 students that could not or that offer both. So that's the answer to this. Very simple. Just know the parameters. Anyone that is not given in the question, no problem. If you are not giving people that offer that is not offering any of the states, you will use this part to solve. But this number will not represent the total students or the total survey or the total category of what you are looking at. It will represent the union of A and B only, without the other parts that is not included in A and B. This side will represent union of A and B only. So let's take another example. You understand what I'm saying? Look at this one. We're told that 25 students do sewing out of 40. 25 students do sewing, that is, they do sewing, they learn how to sew clothes out of 40. If there are 30 students, if there are 50 students in the survey, where some do nothing, of the students do nothing, and some do nothing, and let's say 30 do skipping. So 30 of the students do skipping. Okay? So how many students do both? So it has to do with the intersection again. This question has to do with intersection. So how many students do both? In this question, you approach it similar to the first one, but you must take account that we are told that some students do nothing. And how many students were surveyed? In 50 students total, and 40 were the ones that involved the two sets. That is the people that do sewing and people that do skipping. Total amount should be how many? 40. So these 50 students, meaning that some of these students, which is apparently is clear that 50 minus 40 will give you 10. So that means 10 students do nothing. So that's why the question was not centered on finding the number of students that do nothing. In this case, what are you going to do? What you are going to do is very simple. You are going to use this total number of students that actually do something, then you compare with what they do, skipping and sewing. Number of students that do sewing, number of students that do skipping. That is 30 do skipping, and 25 do sewing. Use 30 for skipping, 25 for sewing, and use a total of 40 to determine the answer without involving the students that do nothing. So that means that solution, remember that there are 4 compartments normally. Should have been number of elements in first one plus number of elements in second one minus the intercept plus those that do neither. But in this case, we don't do the neither part. So it's going to be number of students that do both what? Sewing and skipping. Let's call A sewing, unions, let's say B is skipping. So this will just give you number of students that do sewing, which is what? 25, plus number of students that do skipping, which is 30, minus students that do both, which we are looking for. Only. This is the part we are going to use. Number of students that do both skipping and sewing, total of how many? Is 40. Don't forget that. So there's no need of putting plus the people that do nothing. If you put plus people that do nothing, this part here will become universal set. Do you understand? It will become the universal set. That means you're going to use this 50 to solve. Okay? Of course, if you are using 50 to solve here, you have to put 10, which means that 10 students do nothing because 50 minus 40 will give you 10, and you still arrive at the same answer. You can try it out. You can try it in your book now and see. So 40 will be equal to what? 25 plus 30 minus x. And one thing about this is that the total number here must always be greater than this, because it is only when it's greater than this that when you subtract something, it will give you a value here. Take note that the total number of students mentioned or survey, total number of category of sets mentioned must always be greater than the number of combined, so as you can get both. Do you understand? Because if exactly the same number of students do both, do this and this, that means there will be no student that do both, and there will be no intersection in the set. So take note of that to help you in exam. So this is 55 plus x, and this is 40. So if you do what I did the last time, this one comes to this side, sorry, minus x. So if the x comes to this side, so x is going to be what? X is going to be 55 minus 40, and that will give you 15. So there are 15 students that do both sewing and skipping. I will take the final example. Anyhow the problem comes, follow this approach, you get the answer. Let me take the final example that involves when the numbers are not mentioned. Rather, you represent them with what? You represent them with x, or the number of students that do both is given as x, or also known, and you are required to subtract it from both sides. You will also get the same answer. So let's take that example, which is the final example for 6. So if you have a case, I will represent with the diagram. If you have a case where you have two sets, okay, and here is 40, and here is, let's say, 60, and here is 10, okay, and you're asked to find, okay, let's say here is x, and here is 10, okay, and here is 30, okay, here is 30, and let's say the universal state is 65. It's 65. The universal state is 65. This is that's the intersection between the two sets. This is 30. This 30 includes everything, including this x. So x is part of 30. Do you understand? So x is part of 30. Then this part here, we are asked to find what is here. So in this kind of situation, how do you do? Or let's say here, let me just give a value for x. Let's say x is 12. 12. And you're asked to find here, let's give this list, let's call this list y. So in this kind of case, what do? You're asked to find the number of people in this set. Let's call this set P, and let's call this set Q. So remember, the formula still remains the same. It doesn't change. So the universal set, which is 65, will be equal to everything in A, in P, everything, including this 12. Everything in P, including this 12, which is going to be what? 30 plus 12, remember. Plus everything in this other set, including this 12, which will give you what? Y plus 12 minus the intersection, which is what? 12 plus what is outside, that is neither. That's a prime, okay? The P union Q prime, which is what? 10. So if you set it up like this, you are going to have 42 plus what? Y plus 12 minus 12. 12 you cancel 12. So you have y here plus 10, and that is 65. So if you do the mathematics, you have 52 plus y will give you 65. And y will give you what? 65. Y is equal to 65 minus 52, and that will apparently give you 13. So that means there are 13 students in this set. And how many students are actually in set Q? Total number of elements in set Q will be what? So therefore, number of elements in Q will be what? Not just 13, rather it will be 13 plus what? 13 here plus what? 12. Meaning there are how many? So the number of students that offer that is in part of Q is actually 25 and not 13. Take note. If you are asked for people that do only Y, that are elements of only Y, it will be 13. But Q, that's the full set of Q, is going to be 13, which will found as Y, plus the intersection of 12. Don't forget that. Give you 25. So both of them might be in the answer. You don't know which one to choose. So that is summary of what you must remember about sets. Remember the formula I gave earlier? and how to set up the formula to analyze. So thank you, that is for sets. Alright, so I'm switched over to simultaneous equation, which is the second part of your syllabus. So in the simultaneous equation, you are going to go straight to the point. Remember that any equation of when we have two linear equations that you are solving at the same time with two variables, it's said to be simultaneous equation, okay? For example, if you have x plus 3y, and we are told is equal to 4, and we are also given that 2x minus 4y is equal to 11. These are two pairs of linear equation in two variables. So two variables are unknown, x and y. To solve this equation, to find the value of x and y, pairing the two and solving at the same time is a method called simultaneous equation solution method. And of course, we know there are three basic methods. There are actually 5 methods to solve. But the 3 major methods you use in your exam is what? We use the graph, which I'm not going to cover. You will not have time to look at graph in the hall. But if you look at graph, you're able to read up the answer easily by looking at the intercept and the slope. You arrange this equation, okay, and draw the lines and see where the intersect. With a point of intercept will give you the solution of the simultaneous equation. That is easy. Maybe if we have time, we'll cover it. We have what is called substitution method or equating coefficient. Sorry, substitution method, not equating coefficient. By method of substitution, or we have the elimination method or equating coefficient. So the elimination method is also called equating coefficient. So the aim is to make the coefficient of one of the unknown variables equal. So when you equate the coefficients, you can easily eliminate that variable and solve for the other one, and finally you still substitute. So whichever method you use, you still substitute. So the substitution method and the elimination method is they also have the matrix, the use of determinant and the use of the inverse of the matrix, okay? So Cramer rule, that's the determinant method, is called Cramer rule. So I'm going to cover substitution and elimination method basically, because that's what you need for easily assessing your answers in exam. So let's start. We'll take some problems and we'll solve it. Then we'll look at what problems involving simultaneous equation 2. The first example we're going to solve includes the following.